In 1920, a small company in Stephen, Minnesota, built a machine that would change the course of American infrastructure. The Russell Motor Highway Patrol No. 1 was the world's first self-propelled motor grader. It had 12 horsepower, a 6-foot blade standing 13.5 inches high, and a top speed of 3 miles per hour. Russell built exactly 172 of them before production shut down permanently in 1926. 172 machines. That was it. That was the entire production run of the first self-propelled motor grader ever made. But here is what makes that number extraordinary. By 1928, Caterpillar bought Russell and used it as the foundation for what would become the most dominant motor grader program in the world. By 1931, Caterpillar redesigned the concept entirely with the Auto Patrol. By 1938, a single Caterpillar grader model sold over 17,000 units in its first decade, more than the entire industry had built in the previous 20 years combined. Every motor grader rolling off assembly lines today, from Caterpillar, John Deere, Volvo, and Komatsu, traces its fundamental design back to that 172-unit machine from rural Minnesota. That is an extraordinary engineering legacy, but the human cost of getting there was staggering. In the early 1920s, roughly 30,000 Americans were dying on the job every year across all industries. The overall workplace death rate stood at approximately 61 fatalities per 100,000 workers. Construction was consistently among the deadliest sectors, with estimated death rates of 150 to 200 per 100,000 construction workers. American construction workers were 2 to 3 times more likely to die on the job than their counterparts in European nations. One prominent skyscraper construction firm openly admitted to averaging 1 worker death for every 33 hours of employed time. The prevailing attitude of the era was captured in a blunt observation from the period. There was a general perception that it was not legitimate work if the job was completely safe. The motor grader operator occupied a uniquely dangerous position, even within this deadly industry. He stood on an open steel platform with no cab, no seatbelt, no rollover protection, and no protection of any kind, hand-cranking worm gears against heavy loads while an unmuffled engine roared beside his head. At least one documented death resulted from a pull grader operator being thrown violently into the blade adjusting wheel mechanism after the blade struck a large buried rock at working speed. He had nothing to protect him, not a restraint, not a railing, not even a handhold between his body and the heavy steel controls. For comparison, the modern workplace death rate is about 3.5 per 100,000. That is a decline of over 90%. And today, a motor grader operator sits inside a climate-controlled Key AB with GPS-guided blade control accurate to the millimeter. But in the 1920s, these men earned $2.25 a day, roughly $42 in today's money, to operate machines that could kill them through normal use. So how did 12 horsepower machines crawling at 3 miles per hour end up building the highway network for 26 million automobiles? And why did the deadliest industry in America produce one of its most critical inventions from a town in rural Minnesota that you have almost certainly never heard of? The answer starts with roads, or rather, the complete absence of them. In 1904, the first comprehensive national road inventory found 2.15 million miles of rural public roads in the United States, of which a staggering 93% were plain, unimproved dirt. Only 153,662 miles had any surfacing material applied at all. In Iowa in 1920, just 25 miles of paved road existed outside of cities and towns in the entire state. The American Automobile Association in 1921 publicly advised motorists to avoid traveling through the entire state of Virginia because road conditions were so poor. A trip of just 20 miles through a rural area could consume an entire day of travel. The economic impact was severe. The cost of hauling grain 10 miles from a farm to the nearest railroad station by wagon over dirt roads exceeded the cost of shipping that same grain 500 to 1,000 miles by railroad. Farmers were spending more to get their crops to the train than to ship them across the country. But this road crisis was about to collide with an automobile ownership explosion, unlike anything the world had previously witnessed. Vehicle registrations across the United States surged from 8 million in 1920 to 26.5 million by 1929, more than tripling in a single decade. Americans drove 55 billion miles in 1921 and 206 billion miles by 1930, nearly quadrupling total miles driven in just 9 years. Henry Ford's Model T had driven this transformation by making car ownership accessible to the working and middle classes. The Model T's price dropped from $805 when it was introduced in 1908 to just $310 by 1921, cheap enough that a factory worker could buy one with a few months of savings. By 1920, 1 in 3 American farmers owned an automobile, and those farmers were demanding roads that their cars and trucks could actually drive on without getting stuck in mud for hours. The existing road network was physically incapable of handling this flood of vehicles. Dirt roads that had served horse traffic adequately for decades turned into impassable mud pits under the weight and speed of automobile tires. Therefore, the federal government acted. The Federal Highway Act of 1921, signed into law by President Warren G. Harding on November 9, 1921, appropriated $75 million in federal funds with a requirement for 50-50 matching contributions from each state. It doubled the per-mile federal contribution limit from $10,000 to $20,000. And most critically, it required each state to designate an interconnected highway system comprising no more than 7% of total road mileage, on which all federal funds would be concentrated. This replaced the previous 1916 Act's scattershot approach, which had produced disconnected road fragments across the landscape, roads leading essentially from nowhere to nowhere. The money was massive. The ambition was unprecedented. But there was a problem. Someone needed to build machines capable of grading hundreds of thousands of miles of road surface. And in 1885, those machines did not exist yet. The invention that would make them possible came from a road inspector in Indianapolis who was tired of watching horses struggle. Joseph D. Adams spent his days traveling the dirt roads of Indiana, watching horse-drawn scrapers fight a losing battle against basic physics. These early scrapers were crude implements, basically a steel blade dragged behind a team of horses. They could push dirt sideways, but they had a fundamental engineering problem. Grading work generates a lateral side load. When you angle a blade and push earth to one side, the resulting force shoves the entire machine off course. A rigid frame scraper fights this force constantly, and the horses pulling it waste enormous energy just trying to stay on line. Adams invented a deceptively simple solution. He built a 2-wheeled grader with wheels that could lean sideways, and he called it the Little Wonder. The concept was elegant. When the blade encountered side load from moving earth, the operator could tilt the wheels into the load, leaning the entire machine's weight against the lateral force. The principle is the same as a worker leaning into a heavy wheelbarrow to keep it tracking straight. Instead of fighting the physics, the leaning wheel worked with them. This single innovation transformed the road grader from a surface scraper into a genuine earth mover capable of cutting ditches, shaping road crowns, and building proper road profiles with drainage slopes. By 1896, Adams had developed the Road King, a 4-wheeled, all-steel horse-drawn grader equipped with an 8-foot blade and wheels that could lean in either direction. Nearly every competing manufacturer eventually adopted the leaning wheel principle. The one notable holdout was CD, Edwards Manufacturing, whose 1924 product catalog proudly proclaimed that rigid wheels were the superior engineering choice. The market disagreed decisively, and Edwards lost that argument to the point of irrelevance. But Adams himself faced a problem that had nothing to do with engineering. He lacked manufacturing capability. For years, he worked as a traveling salesman across Indiana, hiring contract manufacturers to build machines that he sold directly to local government road agencies. By 1897, he had finally established his own factory in Indianapolis. The J.D. Adams Company would grow into one of the most respected names in greater manufacturing. A documented purchase record from Rush County, Indiana, shows that a J.D. Adams leaning wheel grader number 12 was bought in March of 1922 for $1,140. Adams had solved the physics, but every one of his machines still required a team of horses to move. The breakthrough that came not from Indianapolis, but from Minneapolis, and it came from a company that was about to build something the world had never seen. In 1919, engineers at the Russell Grader Manufacturing Company took an Allis-Chalmers wheel tractor and combined it with one of Russell's own highway patrol pull graders. They bolted the grading implements to the tractor frame and connected the blade controls to the tractor's power system. The result was the Motor Highway Patrol No. 1, and it entered commercial production in 1920 as the world's first self-propelled motor grader. The specifications reveal how primitive this pioneering machine truly was. A 6-foot blade, standing just 13.5 inches high, a gasoline engine producing 6 drawbar horsepower and 12 brake horsepower at 1,000 RPM. Top speed from 1.5 to 3 miles per hour on 48 by 8-inch smooth steel tractor wheels. A turning radius of 36 feet, Russell's marketing department claimed the Motor Highway Patrol would do the work of 3 full teams of horses. That claim was probably optimistic, but a self-propelled grader controlled by a single operator could maintain roads without depending on horse teams that needed feeding, resting, and replacing. Production ran from 1920 until 1926, when Allis-Chalmers discontinued the specific tractor platform Russell depended on due to a patent dispute with another manufacturer. In those 6 years, Russell averaged roughly 29 machines per year. The self-propelled motor grader was an invention that almost nobody had asked for yet. But the machine Russell created was about to put its operators through a special kind of hell. Controlling the blade on a 1920s motor grader was not just difficult, it was physically destructive. The blade had 5 separate degrees of adjustment that the operator needed to manage simultaneously while the machine moved over rough, uneven terrain. Height meant raising and lowering the blade to set cut depth. Angle meant rotating the circle gear ring to change the direction the blade pushed earth. Slope or tilt meant lifting one end higher than the other to create cross slopes. Pitch meant tilting the mold board forward or backward to change how aggressively it cut. And side shift meant lateral positioning, left or right of center. Each of these 5 adjustments was controlled by its own hand wheel connected to worm gears and rack and pinion mechanisms that the operator cranked by hand while simultaneously trying to maintain balance on a moving, pitching steel platform. The circle itself, the large rotating ring that controlled blade angle, was turned by a self-locking worm gear equipped with a friction brake that held the blade's position against the constant back pressure generated by the earth being moved. Turning this circle gear required substantial force, especially when the blade was under heavy load during deep cuts. Pull-type graders, which remained the most common configuration throughout the decade, required a crew of 2 men. A tractor operator sat at the front, driving the machine forward, while a grader operator stood on a simple exposed platform at the rear, wrestling the hand controls. There was no communication system between the 2 men beyond hand signals and shouting over the engine noise. As one collector who has restored and operated a vintage pull grader described the experience, "You would not want to arm wrestle the man who ran one of these machines 10 hours a day, 6 days a week." It was a beast to operate. But not all graders were created equal, and that brings us to a rivalry that defined the industry. A well-balanced J.D. Adams grader could reportedly have its control wheels moved with just 2 fingers, thanks to superior engineering of the leaning wheel geometry and control linkages. The Adams was so much smoother that operators who had used competing machines described the difference as night and day. But the Adams was the exception, not the rule, and it came at a premium price that many road departments could not justify. Russell's answer to the control problem was different. Rather than engineering smoother mechanisms, they introduced an auxiliary gasoline engine mounted on the grader frame in the early 1920s. This small engine provided mechanical power to assist blade adjustments, replacing the purely manual hand crank system that was physically destroying operators over the course of long shifts. It was a significant improvement for the operators who had access to it. But adoption was neither universal across the industry nor immediate, even among Russell's own customers. Most operators throughout the decade were still cranking by hand. The operating conditions surrounding those controls made everything worse. The operator sat or stood on an unpadded metal seat or platform with no cab, no roof, no windshield, no seatbelt, no hearing protection, and no rollover protection. There was nothing between the operator and the sky, the ground, or the rolling machine around them. The unmuffled gasoline engine, positioned mere feet from the operator's head, likely exceeded 100 decibels throughout the entire shift. For context, modern enclosed cab graders still produce 80 to 95 decibels inside the cab. Steel wheels transmitted every rut and rock directly into the operator's spine through a rigid frame with 0 suspension. In summer, radiant heat from the engine compounded the misery. In winter and rainstorms, there was no shelter whatsoever. The physical toll was devastating, and modern research allows us to quantify the damage even across a century. Contemporary studies show that 53% of heavy equipment operators suffer chronic lower back pain even when using modern machines equipped with air ride suspension seats that reduce whole body vibration by 30 to 50%. The 1920s operator received completely unattenuated mechanical shock through a rigid metal seat mounted on rigid axles, rolling on steel wheels over unimproved dirt roads. The specific combination of spinal compression, flexion, and rotation that characterizes motor grader operation, caused by constant side-to-side rocking as the machine traverses uneven ground, is the exact biomechanical loading pattern most strongly associated with lumbar disc herniation. A single severe jolt on compacted ground could cause acute disc injury in a spine already weakened by hours of cumulative vibration exposure. Standard work schedules compounded every danger. 9 to 10-hour days, 6 days per week, were the norm. Road workers earned between $2.25 and $5 per day, equivalent to roughly $42 to $93 in today's money. Skilled equipment operators earned approximately $1.14 per hour in 1923, about $21 per hour in current terms. Workers lived in rough construction camps near the job site, where they typically paid 75 cents per day for basic room and board. In many states, they had no workers' compensation coverage at all if they were injured. Compare that to the modern motor grader operator's median wage of $28 to $40 per hour, earned inside a climate-controlled cab with rollover protection, air ride suspension, and hearing protection. But despite these conditions, men kept showing up. American construction workers were 2 to 3 times more likely to be killed on the job than their counterparts in European nations during this period. And yet the labor supply for road crews never dried up. The jobs paid more than farm work. and for many men in rural America during the 1920s, operating a grader was the best-paying work available within 100 miles. So the demand for graders was exploding, and 6 manufacturers were locked in an aggressive fight to supply a market that most road departments had not yet decided they even needed. Russell Grader Manufacturing Company, founded in 1903 by Richard Russell and C.K. Stockland, had the first mover advantage. Beyond building the world's first self-propelled motor grader, Russell offered one of the deepest product catalogs in the industry. Their line ranged from the simplex pull grader, a basic horse-drawn model selling for $105 to $150, up to the massive mogul with a 12-foot blade requiring a 25-horsepower tractor. By World War I, Russell had established dealerships in 27 cities across the United States and Canada, plus export operations to Australia, Africa, and South America. They even sold graders to the Russian government for military trench digging along the Eastern Front. But Russell's first mover advantage did not guarantee survival. When Alice Chalmers pulled the rug out by discontinuing the tractor platform, Russell had to pivot to the McCormick Deering 1020 tractor for its No. 3 motor patrol from 1925 to 1929. The company's independence was running out. J.D. Adams of Indianapolis had the engineering advantage. Adams graders were known for precise, well-balanced control mechanisms that made their machines dramatically easier to operate than anything from their competitors. The leaning wheel principle that Joseph Adams invented in 1885 was so fundamental that virtually every manufacturer in the industry adopted it for their own machines. But engineering excellence did not translate into market dominance, and J.D. Adams was eventually acquired by Letourneau Westinghouse in 1953. The leaning wheel principle, however, remains fundamental to every motor grader ever built. Galion Iron Works, founded in 1907 by the Boyd brothers in Galion, Ohio, had the most forward-looking vision. Their motto was, "All roads lead to Galion," and they worked hard to earn it. Galion's product line included some of the largest pull-type graders available. Their No. 14 model featured a 14-foot blade, weighed 15,000 pounds, and required the largest available agricultural tractors to pull it. But Galion's most consequential contribution was their early development of hydraulic grader controls during the 1920s. While these early hydraulic systems were primitive, Galion was pioneering the technology that would eventually render every cable and mechanical control system completely obsolete. Jeffrey Manufacturing Company acquired Galion in 1929, before Galion could fully capitalize on the hydraulic revolution they had started. Austin Western traced its origins to 1877, when Captain C.H. Smith, a veteran railroad construction foreman, founded the Western Wheeled Scraper Company in Mount Pleasant, Iowa. The company's historical claims were ambitious. They asserted that they had essentially invented the road grader itself, pointing to their earliest products, steel blades mounted underneath freight wagons. Whether that claim holds up is debatable, but Austin Western was among the earliest and most innovative companies in road equipment. They became famous for multiple industry firsts, including the steel reversible road grader, the motor roller, and the dual-drive leaning wheel grader. Their equipment was used in the construction of the Panama Canal. Champion Road Machinery had roots going back to 1877 as well. The company's Canadian branch became the independent Dominion Road Machinery Company, operating from the town of Goderich in Ontario, manufacturing crushers, screening plants, and multiple sizes of graders for the Canadian market. But all 6 manufacturers faced the same competitive reality. Most road departments were still comfortable with horse-drawn equipment, or simple tractor-pulled graders costing a fraction of the price. Rather than designing purpose-built machines, most manufacturers bolted grader frames onto existing farm tractors already in mass production. The McCormick Deering 1020 became the universal platform. Russell used it, Adams used it, Galion used it, Champion used it. These were hybrid contraptions with the engine at the front, the blade in the middle, and the operator perched on whatever platform the manufacturer had welded behind the engine. Functional, but awkward, with poor stability and blade precision compromised by flex in the bolted connections. The total fleet of self-propelled motor graders operating in the United States during the 1920s likely numbered in the low hundreds. The overwhelming majority of grading work was still performed by horse-drawn or tractor-pulled equipment. Volume production would not arrive for another decade. But one company was watching this fragmented industry and preparing to consolidate it entirely. On December 4, 1928, Caterpillar made its move. The acquisition of Russell gave Caterpillar its new road machinery division, and graders became their first product line outside of crawler tractors. It was the beginning of Caterpillar's transformation from a tractor company into the diversified heavy equipment giant it would become. But Caterpillar did not buy Russell just to continue building the same primitive machines. In April of 1931, Caterpillar introduced the Auto Patrol, and it was a machine from a completely different era. 14,000 pounds, 35 horsepower diesel engine, a 12-foot blade, pneumatic rubber tires instead of steel wheels, transforming both operator comfort and grading precision. A long wheelbase designed for stability, and the first fully power-operated blade controls on any production motor grader. A drive shaft conveyed engine power through worm gears to a central power distribution box, which directed force through sliding jaw clutches and universal joints to each blade adjustment mechanism. Operators quickly gave this system the nickname finger slapper, because the dog clutch engagement levers snapped back to neutral with considerable force and could strike the operator's hands painfully if they did not pull away quickly enough. That finger slapper design, which was itself considered a massive improvement over the hand cranks it replaced, remained standard until hydraulic controls gradually took over through the 1940s and 50s. The Auto Patrol did not just replace the hand-cranked machines, it erased them. And when Caterpillar followed it with the number 12 diesel grader in 1938, volume production finally arrived for a machine category that had spent 2 decades in the margins. The scale of what those 1920s machines and operators accomplished is genuinely remarkable. The Federal Highway Act employed over 250,000 workers across all 48 states. By the end of 1922 alone, 10,000 miles of new highway had been added to the national network. All 48 states had enacted gasoline taxes by 1929, creating dedicated revenue streams, and by 1927, total annual road spending exceeded $1.5 billion. Surfaced road mileage across the nation more than doubled, growing from 257,000 miles in 1914 to over 521,000 miles by 1926. Illinois emerged as the decade's road-building champion, completing over 5,434 miles of paved roads by 1926, with annual construction accelerating from 413 miles in 1921 to 1,230 miles by 1924. Every single one of those miles required motor grader work before the first yard of concrete could be poured. Every mile of new paved highway required precise grading of the subgrade, establishing proper elevations, cutting drainage ditches, shaping road crowns for water runoff, and building the slopes specified by engineers. Meanwhile, the millions of miles of dirt roads that remained unpaved required constant regrading after every significant rainstorm. Without the motor grader, the entire 1920s road-building boom would have been physically impossible to execute. An 18-foot-wide concrete road cost approximately $28,000 to $38,000 per mile, equivalent to roughly $530,000 to $704,000 today. Modern road construction typically costs $2 to $3 million per mile. The price range of 1920s grading equipment reveals the economic realities. A basic Russell Simplex horse-drawn pull grader sold for $105 to $150. The J.D. Adams leaning wheel grader cost $1,140. Self-propelled motor graders of the late 20s likely cost between $1,500 and $3,000, equivalent to roughly $28,000 to $56,000 today. Modern motor graders sell for $200,000 to $500,000, but deliver exponentially greater capability. 200 to 500 horsepower versus 12 to 35 horsepower. 12 to 24-foot blades versus 6 to 8-foot blades. Enclosed climate-controlled cabs versus exposed steel platforms. GPS-guided blade control accurate to the millimeter contrasted with hand cranks that could break an operator's wrists. Safety features that would eventually transform this industry all lay decades in the future. Rollover protective structures were not available until the mid-1960s, and they were not mandatory until 1974. When combined with seatbelts, ROPS are 99% effective at preventing operator death in a rollover. Enclosed cabs arrived gradually through the 50s and the 70s. OSHA was not created until 1970. The progression from hand cranks to finger slappers to hydraulics to electronic joystick controls represents one of the most dramatic improvements in operator welfare in the history of construction equipment. The 1920s motor grader sits at one of the most dramatic turning points in construction history. In a single decade, the machine evolved from a horse-drawn scraper requiring a team of horses and a man walking behind it, to a motorized contraption that was brutal, primitive, and absolutely indispensable to the nation that depended on it. The men who stood on those open steel platforms throughout the 1920s, cranking worm gears against heavy loads and absorbing every jolt through their spines while unmuffled engines roared beside their heads, built the road network that transformed the United States from a nation of isolated rural communities connected by mud and wagon ruts into a continent spanning automotive civilization. They did it for $2.25 a day, in an era when 30,000 Americans died at work every year, and a grader operator could be killed by his own machine if the blade struck a buried rock at the wrong moment. The future of hydraulic controls, enclosed cabs, and air ride suspension was still impossibly far away. Today, a modern motor grader operator adjusts a 12-foot blade using a joystick inside a climate-controlled cab, with rollover protection tested to survive a full inversion at speed. Modern joystick controls reduce hand and arm movement by up to 78% compared to even lever-operated systems. That transformation took 100 years. The men of the 1920s paid for every inch of it. If you found this look at early motor grader history as fascinating as we did, hit like and subscribe. We cover construction equipment history, industrial disasters, and the machines that built the modern world every single week. If you want to see how operators survived before hydraulics on bulldozers and scrapers, check out our full Before Hydraulics series. The link is on screen now.